Welcome to the BGP troubleshooting video part 2. So now in this scenario we are going to talk about a new case where we will use the same topology. R1 is in AS100, R2 is R21 is in AS200. These are the IP address. So the topology is same, but the problem is new. So let's look into this case and let's try to find out why the BGP session is down over here. So we see that over here also the BGP state is active. It never came up. Let's look into the details like show IP BGP neighbor 10 1 21 2. Okay. Okay, sorry, I did a typo. Show IP BGP neighbor. So over here what we see is like it's active state. So it's not idle connect, it's active state. It means there is kind of IP reachability because we can see that there are open messages sent and received, but the BGP is not established. So it could be something mismatching in the IP state, in the open state, right? So now let's look. Oh yeah, one more interesting thing we can see over here is about the timers. You see over here, there is hold time 60, keep alive 20 second, which is not the standard one. Standard is hold time 180, keep alive is 60. So obviously we can see over here that there has been some sort of tweaking. So we can see it in the next line. So the configuration changes over here is like hold time 60, keep alive 20. So there has been like some configuration changes over here. This is not the standard one. So this could be one of the possible reason, because we know that at the open within the open messages there are stuffs like hello timers are being matched, AS numbers are being matched, right? So these parameters are being compared. So if we can see that there are some open messages being sent and received, and still we don't see the BGP state going to establish, then this could be the reason. Another interesting thing is that this connection never established, so it's just a fresh connect, it's just a fresh connection, right? So now let's look into some more stuffs like we can go into the logging, right? And then we can see what's going on the logging, right? So let's go into show logs. So the show log is not enabled over here. Okay, so what we can do is like we can go to configure terminal. Okay, and then we can do something like logging buffer, no logging, yeah, logging buffered, right? So now as soon as we do this, then if we go and do show log, we can see if, yeah, some of the messages will start whenever there is a console message, it will appear in the log, right? Another option is like we can also run some debugs over here. We can do some Wireshark to see what's going on, and let's me see if there are some log being captured or not. Until now we don't have any. So let's try and check log if we are seeing anything in the log. So we do see that in the log we have messages like BGP notifications are coming actually, and the notification says unacceptable hold time. This notification is coming from the neighbor. So now we have very clear idea right now that there are some mismatch related to the timers in this scenario. But before I jump into the configuration and I show you what is the configuration issue, I like to do some more troubleshooting. Like we are in lab right now, we are just practicing stuffs. So why don't we run the Wireshark and let's look more into it. Okay, so let's, because you know the Wireshark is very huge, so I will actually filter on the top. So I am going to do something like source, okay, sorry, address IP source host 10.1.21.1. So now over here I have filtered using the R1 IP address. So I'm seeing what R1 is sending. So here I can see the R1 open message. So the R1 open message, let's look into it. We can see that R1 is sending hold time 60. We can also see the what is in the R21. So let's put the source IP address of R21. If we put the source IP of R21, we can see here is the open message for R21. We can see the hold time from over there is 180. Okay, now if we look into notification, we can also see the same as the log message. We can see unacceptable hold time. Now you guys must be thinking that hold times can be negotiated, right? So yes, it's possible. Like let's say if I configure a lower hold time and my neighbor is able to negotiate it, then if negotiation is allowed, then it is going to negotiate and we are going to agree on a lower hold time and lower keep alive. But in certain scenario, like in this lab, there is definitely some hard-coded information over here due to which we cannot configure such a low value of hold time. Okay, so this is the reason why we are receiving the messages like over here from our neighbor saying that unacceptable hold time. So this is the scenario of hold timers. Okay, let's try to fix it now. Config, before I go to the config terminal, let me show you show run section BGP. So, okay, show run section BGP. Now we are looking into the configuration. So this is exactly as we expected. So since we know that the neighbor is not playing with us, it's not allowing to change the timers, right? So the values that we have put is unacceptable. So let's try to remove them, right? And then let's see if the neighbor comes up. Router BGP 100, and I will do timers BGP. Let's do no timers BGP. No timers BGP. So the first parameter over here is the keep alive. Okay, so the keep alive by default it's 60, but over here it was configured as 20. But right now we are removing it so that it goes back to the default. So this is the keep alive. Next is hold, and then the minimum hold. So we remove all of them, and then now what we are going to see is show run, oh man, show run pipe section BGP, and we can see over here it's already removed. Show IP, show IP BGP summary. And once we see the BGP summary, we see that just 2 seconds back, this BGP session came up. Now, so this one was related to the timers, but now I will be looking into some more scenarios, some more troubleshooting example. So let's jump into the next scenario. Now in this scenario, we are looking at 3 routers instead of 2. Now what we have over here is same R1 in AS100, R21 and R22 are in AS200. The loopback IP of R1 is 1.1.1.1. Here the third octet follows the router name. So for example, R1, the loopback third octet is 1, right? For in case of R21, it's 1.1.21.1. In case of R22, it's 22 in the third octet. Now in this scenario, the problem that we are facing is that the BGP is not coming up between R21 and R22. It's an eBGP session. Here we can see that 1.1.22.1 on the router R1 is shown as idle. In this router R22, we see that the neighbor 1111 is also idle. So we see that this eBGP session is showing as idle. Now my guess is that usually whenever we see an idle state, it could be that there is no layer 3 reachability, right? So let's do something. Show IP BGP in neighbor 1.1.22.1, and when we go into it, what we see is that yeah, let's see we have the eBGP session. We can see that it's going AS200. It's an external link. Remote router, we haven't received any packets from it. We see sent and receives are 0. This is the reason why we see over here that all the opens packets and notification everything updates is all 0. The other interesting thing we see over here is that yeah, it never came up. There is no prefixes, nothing, and the connection established was 0, which means never established. No active TCP connection, so we are not even able to establish the TCP This is an interesting line. eBGP session not directly connected. In case of eBGP protocol, BGP expect that the neighbor is directly connected. Over here, we see that the neighbor is not directly connected. Also from the topology we can see, but the router is not aware of the topology. Like by this, I mean like it cannot see this diagram, right? But it can see that we are trying to connect the loopback IP address to some router IP address which is not physically on this router, right? The other loopback IP address is not directly connected over here. So this is how the router is assuming that these routers are not directly connected. Now, in case of when the routers are not directly connected, and I just told that eBGP expects that the neighbor routers are always directly connected, there is a way how we can make the remotely connected routers to work. Before I go that path, let me try to ping this router because there can be some IP reachability issue. So from router R22, I have to ping 1.1.1. Okay, and from okay, so I need to use the source interface. I think that's better. So I will use the source loopback 0. Okay, I can ping using the source loopback 0. Like if I use the source loopback IP address, then I can ping the R1. So this part is good. Let's try from the other direction also, just so that we can verify that our IP reachability is smooth. Source loopback 0. Yeah, we see that bidirectionally we can communicate. Let's do one more thing. Whenever we are doing eBGP session and we have a doubt, like over here we can see the topology and we can clearly know that this is indirectly connected neighbor, but there is another way. Let's say if you cannot see the topology and you want to know if the neighbors are directly connected or not, you just do a trace route and you will see that it's not directly connected. It's going via, like, we can see multiple hops over here regarding. So what we need to do next is let's look into the configuration. So show run section BGP. We see this neighbor over here 1122.1. We don't see any eBGP multi-hop configuration. Let's go into config terminal, and then we are going to go to the router BGP AS is 100, and let's do the eBGP neighbor 1.1.22.1 and eBGP multi-hop. This time it is going to be 1. Okay, and do show run pipe section BGP. What we see over here is we don't see the eBGP multi-hop 1 because this is a default value. So if we don't see anything configured, it means that it is still sitting on the eBGP multi-hop 1. eBGP multi-hop, and what options do we have? We can configure from 1 to 255 because TTL 255 is the maximum value. So basically what we are setting in eBGP multi-hop is a time to live value. So let's make the time to live value as 2 because we know it's at 2 hops. Once we configure it, we need to do the same activity over here as well. Config terminal, router BGP 200. Okay, and I will do show run pipe section BGP. Over here we don't see the eBGP multi-hop neighbor 1.1.1.1, and then I'm going to do eBGP multi-hop. We have to set 2. Now once we configure it, so we are now expecting that the BGP is supposed to come up. Yeah, we see the BGP immediately come up, but we want to also see what's going on in the Wireshark. So I have started the capture. So we see over here the first BGP packet I want to go before the keep alive, the first open message. So we first configured on the R1. So this packet is going from R1 to R22. So we see that over here the time to live is, wow, the time to live is 2 because we have set the TTL value as 2. So what happens when the time to live value is 2? We know from our lecture that at every hop 1 TTL is dropped. So the ping will be, the packet will be sent from R1 to R21. One hop is minused over here, like 1 TTL is dropped, then the value of TTL is 1, and then it moves to the R22 where the TTL value, where it will find the BGP neighbor, the IP 1122. In the same way, let's look at the other way around. So R22 is going to send the TCP packet. So this is one hop and this is second hop, right? So let's look into the 1122 open message. Now here we get the open message from the neighbor and the TTL value is 1. So the question is why, when this guy is sending the open message, the R22 to R1, at that time we see the TTL value as 1, because although we have set it as 2, so this box is going to send TTL2 to R21. It will reduce one step and then it will send as a TTL1 to R1. And since we are capturing over here between R1 and R21, so that's why we are seeing TTL as only 1. Okay, so R22 dot to R1 open message and TTL is only 1. But whereas over here, when R1 sends to R22, the TTL is shown as 2. So anyhow, so this was related to our BGP eBGP multi-hop configuration. Before we leave, let's check one more thing, which is the show IP BGP neighbor. Show IP BGP neighbor 1.1.22.1, and let's look into the details. You see now the open messages are there, open message sent and received. In queue depth shows something like we are seeing it 0, which is a healthy number. In queue depth means, let's say if there are lots of update messages coming to the router and the router CPU is very high, it cannot process, so then you will see the in queue depth is increasing, right? In this case is 0, it means that the router is in good shape. Then we have the route refresh and address family IPv4. We have only configured IPv4 unicast. We are not doing the MPLS. When we do MPLS, we will see BGP, VP and v4 family as well. So that's another scenario. And then establishes the BGP state. Right now it is up for 2 minutes. Okay, over here we see the last timers. Hold down time is 180. We have done a lab in previous part for the hold down timers. So hold time is 180, keep alive is 60. Okay, and this is the neighbor capabilities that we are exchanging. In queue depth I just told about. Open is the number of open messages that we have exchanged so far. Okay, other interesting thing we have over here is like yeah, these are the prefixes. So our router has not sent any prefix, but the neighboring router has sent 2 prefixes to us. I will do more lab on the prefix exchange and troubleshooting the prefix installation, active and the exchange of prefixes, some route maps as well. So that will be in coming parts. Then we have yeah, so all these timers related stuff. I'm just looking for the interesting stuffs, which like gradually in future labs I will share all these information like SRTT, RTTO. Okay, so I don't want to like share lots of information because in one video, because the video gets very longer. So in next part I will share more information about other parameters as well. So I will end video over here right now, this part, and then I will make a new part remaining more troubleshootings. Thank you guys, thanks for watching.